Okay, so now we're ready for part 7, velocity versus time graphs, and this is the last part of the lab. But before we do that, let's go back to part 6, and I just want to point out one more thing. The whole point of a scientist making a graph is to try to get a straight line so that they can predict the formula that relates the variables. So here's the formula for a straight line. Y, which is the up and down part, is going to be equal to the slope m multiplied by the sideways part plus the slope intercept. Now in part 6, you found out that this thing went through 0, 0. So that meant that b was equal to 0. So that's not part of the equation. Now, y, when it was a position versus time graph. So we're not part 7 yet. So in part 6, it was a position r versus time graph. So instead of the letter y, let's substitute the letter r for position. Okay, then we had the slope, and the slope turned out to be the what of the object. It was the velocity of the object. So v for velocity, and then instead of the letter x, we're going sideways. That's the letter t. So we're ending up with this equation that the distance something travels is going to be equal to its velocity multiplied by time. And if we were to take the t over to the other side, then that equation would become that v is going to be equal to distance divided by time. Does that look familiar? Well, that's this equation way up here. So what we did was we used the data to figure out what's the relationship between the velocity, the distance, and the time. Wow. That's really impressive stuff there. It is. All right, so now we're ready for part 7. So this time it's going to be a velocity versus time graph. So let me get rid of all of this. And the first thing it says to do is to go back to the velocity versus time graph and note that it has a straight slope. So let's go back to here. Now here's the one that was curving. Okay, now we're going to activate the velocity one. So we're going to turn on this one. So we're looking at this graph right here. Now this part where it goes down and then it goes sideways, we don't care about that part. Okay, so this is the part where he's hitting the wall. So let's not concentrate on that. So what I do want you to concentrate on is this red line right here, and that is a straight line. That's important. So if we go back to here, a straight line on a graph means that something is doing what? So fill that in. Calculate the slope of the velocity versus time graph and record your results below. Now on the previous one, you remember that I said that you could use 0, 0 because on the previous graph it went through 0, 0. But if we go back to here, we can't do it. So you see it's going through right there. Now one of the two numbers is going to be a 0. So the time t1 would be 0, but it's going to have a other velocity. So again, you need to pick two numbers along this line and then calculate the slope. So if we go back, you're going to have what velocity 2 did you use, what velocity 1 did you use, T2 used and T1 used, and then calculate your slope, put that in there, and then also what was the velocity. So what was the velocity that was used in the simulation, and you're going to put that number here, and then put the acceleration used. So put that here. So put in all of the numbers there. Now, let's go to anytime you got a fraction, the numerator is on the top. The denominator is on the bottom. So D, denominator, D down. So the denominator is the bottom part of the fraction. The numerator is the top part of a fraction. So the units for the numerator were what? So look at what numbers that you put in on the top part there. What were their units? What were the units for the denominator down here? And then put them together. So once you know the units that go up here and the units that go down here, you're going to put them together. So the unit for the slope was then, okay, and then that should jog your memory because that's the metric units for a particular concept in physics. Okay, therefore, the slope of a velocity versus time graph is the blank of the object. It's the object's what? Begins with the letter A. Okay. Then number 17, what is the significance of the positive slope? So did you notice that it was sloping upwards? So what does that mean about the concept that you just figured out? Okay, so that is the lab. So now let's go down to the post-lab questions. So what's the purpose of the lab? So to copy and paste. Now this one did have error. A lot of these computer labs, they don't have any error to them, but this one did. So why do you think that sometimes your numbers did not match up? And then what is the definition of velocity? So that's pretty easy. What does a positive acceleration do to velocity? What happens to the velocity of an object if it's not accelerating? So if the acceleration is 0, it's not accelerating. So then what happens to its speed? Number 6, what happens to the velocity of an object if the acceleration has a negative number? Okay, number 7, a ball moves 1.5 meters in 3 seconds. What's its average speed? Pretty easy. Number 8, if the ball in question now moves 5 meters, how long would it take? So use the speed from up here, and now it's going to move 5 meters. So use your formula and solve it for the letter T, and then how long would it take to move that distance? Number 9. If a ball is traveling at a constant speed, then it travels a longer distance for each, let me move this over a little bit, for each second it moves. Does it move a shorter distance each second, or does it move the same distance each second? Number 10, now this time it's accelerating. It has a positive acceleration, so then it's going to travel a longer, shorter, or the same distance for each second that goes by. And then number 11 here. Okay, given the following information about an object, calculate where it's going to end up. So we're trying to find the distance that it's going to move. So you're going to use one of your 3 equations, the how fast, or the how far, or the hybrid equation, to solve this one. So look at what you're given, and then look at those 3 equations and try to figure out which one has all those letters in it. And then for the hard one. Okay, now here's the hardest question here. You're going to take all of this data and you're going to put it into your simulation. So you're going to go back to here. Now we're going to click on the acceleration one. Reset all. Yes. Okay, we're going to put in the initial position, the initial velocity, the initial acceleration, and then we're going to run it. And what you're going to find is you're going to get a kind of weird looking graph. And so you're going to go to snip, and you're going to make a snip of all three of those graphs. And then I want you to paste it right here. And then I want you to explain it. So explain why the three graphs look the way that they do. Because maybe one of the graphs is like this, and then another graph is making some kind of a curve, and then maybe one of the graphs is sideways. I don't know. So look at your three graphs and then explain why does the position versus time graph curve the way it's curving. Why is this one curving the way it's curving? And then why is this one curving the way it's curving? So this is your hard one. So I hope that you enjoyed this lab. So I will then see you again next time for another lab in physics.